Recorded. Yeah, pretty good, don't you think? All right, website. So it just meets on Mondays, face to face. And I'm going to try to do Wednesdays as the second day, the online part. So I'll show you my calendar. It's late on Wednesday that I'm going to do it. So you probably won't see it until Wednesday evening, whatever the second part of the class is during the week. If I don't put it up Wednesday, that means it's going to come up Thursday or Friday, and I will send you an email when it gets put up. So you'll know when the second content is available. So if you don't see it Wednesday, you can send me a note. Possibly I just didn't hit the complete upload thing. But you'll see it one of the 2 extra days, and then I will send you an email to say it's there. Okay. The way it works is you get a lecture today. I'll give you some kind of lab to do over the week until I see you again. And then I'll give you another lecture on Wednesday, what I'm aiming for. And you might have another little project to do. And that's how the class flows. Okay, this is the book. Anybody have it? Yep, one's got it. It's not too expensive, and it has some pretty good case studies in it. So I've done several different books in this class, and they're just, none of them match perfectly. Thought I brought the other ones down just to have it in. For what we want to do, this is one. So this one just covers the alternative energies. This one doesn't cover those as well. But what I found is I was just dissecting this to get the parts out that I want anyway. So I'm like, well, I can live by this. And then it didn't have any good case studies. So this is a better book. So we're going with it. All right, so what is this class? How did it get developed? Where did it come from? So here's the content that we hope to go through. So the advisory committee said, hey, you ought to think about adding a sustainable engineering course to your program. And of course, I was all jacked up about that because I'm kind of interested in it anyway. I'm a builder and a contractor, and I see all the sustainable stuff going on in the built environment. I'm like, my students should have this knowledge, because if you end up doing anything out there that is going to contact the land, you're going to be involved in these concepts of sustainability. Everything's done differently now when we develop land. So we could be involved with LEED. So we're going to cover that in this course. LEED's a program that is involved in the built environment. You could be involved in a LCA. So I want to give you at least the knowledge of a life cycle assessment. Different than a life cycle analysis. Either one, you know, they talk about both. They're a little different. So we'll do analysis and assessment, both of them. These are just things that could show up at work, right? And then if you have a knowledge base in it, that's going to help you. We're going to go through the renewables. So the primary renewables. You won't become a solar installer, but you'll be able to do a solar calculation. Like you'll be able to look up a location, determine solar hours for that location, determine possible wattage generation from a 4-panel setup or something like that, right? And then also play around a little bit with storing that energy and then reusing that energy. So that's kind of fun. I have a solar panel set up in the back. We usually wheel it out if we can get a sunny day in the winter. We might go out on a cloudy day and just see that it does nothing, but that's less fun than actually getting produced. We can take some measurements with that solar panel and get an idea of how much energy we can get from it. We normally go on the roof because we have an array on the roof, and we get to look at it, you know, check it out, that kind of thing. But there is a website also that is public information about our array on the roof. So any array that is producing energy for a public entity or institution like education, you can get access to it. So that's kind of fun because then we can get all the data from that solar array for the entire year. So then we can say, oh, what is this thing producing? You know, what's it doing for us? Is it doing anything for us? Is this the right area to put solar? Is this the wrong area to put solar? So it's pretty fun. And then we go through, let's see, what do we go through? listed. Right there. So we'll do solar. We'll do solar thermal because that's way more effective and a lot cheaper. Wind, biomass, geothermal. And then I toss in a couple more like wave. Super fun to do wave because we have a wave generator offshore now in Oregon. That's a test generator. It's doing pretty well, but where I was in San Diego, Solana Beach, there's a giant wave generator straight off from the beach. I was like, no way. So I tried paddling out to it. Didn't get that close to it before the little boat chased you away from it, but it was huge, huh?
Where's the one in Oregon?
The one in Oregon is off of Newport, but it's south and in an area that you really can't get to because, as we'll talk about this, the problem with any kind of ocean generation in Oregon or the West Coast is we value the view of the coast. So we don't want to see this thing there. So it gets shut down every time it gets proposed. Same with the tidal systems that work onshore, which we'll talk about. I mean, they can be built to look like rock, like you would never know it's there, but we still can't do it. And much of our coastline is owned by the public. So
Is it not possible to do it underwater?
You
Is all
can't-
the wave on top? Or
No.
is it the current?
yeah, there's one that can be underwater, but that's got to be directly onshore. Yeah. So that one they do in streams, that just uses the current. But you can do that onshore too, because the waves are coming in and going out, and that can, move a thing, right? Which then creates rotation, which then creates power.
Is like a dam, like hydropower, is that considered sustainable?
No, that's hydro. And we'll do hydro
Or
too.
is it not?
That's its own.
Okay.
It's definitely sustainable. It doesn't come into renewables for some reason.
Okay.
And that's mostly because it's just not in a lot of locations. We're super spoiled in this area because
Right.
we have hydro.
Right.
But
Several.
go to Idaho, not a lot of hydro going on there, we have big rivers that we've already dammed up. But you can't do that anymore.
Yeah,
No.
bad for you.
Many of the systems right now on hydro are actually,
Oh.
the federal government is removing a lot of that.
Opposition in everything. Everything you want to do as far as any kind of renewable, there's opposition to it.
I
So,
think in Washington State, they already removed about five
yep.
times.
Yeah, and we'll talk, it's sustainable engineering, so we'll talk about the issues. Sustainability doesn't get into climate change. So a lot of people walk in thinking, oh, I'm gonna learn about climate change. Well, you might learn about climate change, but sustainability has nothing to do with climate change. Sustainability has everything to do with sustaining the current environment, just sustaining it. Like, be nice to improve it, but if we could sustain it, that'd be good, because we don't have a track record of doing that, so. And the environment is essentially air. We would like clean air to breathe. Water, we would like clean water to breathe. Land, we'd like clean land to live on. I mean, that's it. There's not a lot of other things. You can kick energy in there because we need that. That's become a need. So anyway, we go through these and you learn about each one kind of individually. Again, you're not going to be like installer level knowledge, but you should be able to like go, oh, I know how wind creates electricity. And I can even do a simple calculation to estimate how much energy we could get. So that's kind of the knowledge out of the renewables. And it's kind of fun. So what else do we have here? Revit is a big part of this class. So you're gonna learn a new software. For those of you learning other softwares, guess what? You get another one. This one's called Revit. This has gotten my students jobs. There's one little class and one little Revit experience because there's not a lot of people teaching Revit and doing with it what we're gonna do, which is energy modeling. So with Revit, which is an Autodesk product, so this is AutoCAD, right? Most of you maybe seen that. This is Revit, and Revit looks, let's just open one. Revit is a three-dimensional modeler of the built world. Revit is a big memory suck. So if you go to try to download it, which students do all the time, but it just takes a lot of space and a lot of computing power. And I feel like it was flickering the lights. So what Revit can do is this kind of work. It three-dimensionally models structures, right? You can get all the way down to the 2x4s and the 2x6s. And then you can add insulation. You can add an outside barrier, like if you have siding on a structure, you can add a roof. You can add insulation on the roof. All of the parts of the structure get the exact material you want to use. Right? So you're not just kind of fake modeling it, you're actually giving it that material. Then you can take this structure and set it somewhere. Gresham, Oregon, Prineville, Oregon, Astoria, Oregon, right? You can put it in that environment. Revit understands what that climate is, where the sun tracks. You can pick your time of day and year. So you can say, I want to do this energy model July 8th, 2024. And it'll run at noon, right? When the sun is high. It'll run the energy model of the structure. You give it an inside temperature, it'll calculate the outside temperature based on weather data, and it'll tell you how much energy it's going to cost to cool or heat the structure. It's called energy modeling. And it's pretty big. So anything commercial that gets built this day and age is going to have an energy model associated with it. Might not be Revit, there's other softwares that do it, but Revit is a super popular one for this kind of work. So that means if I'm a builder and I'm building construction, commercial construction, and you want to pay me to build your building, right? So you tell me all about your building, I model it, and then I can say, okay, it's going to cost you this much to heat it. And then that's good information for you, right? But then I can say, hey, if we just widen the walls out, put in a little more insulation, let's make the ceiling a little deeper, let's make the footprint, turn it a little bit so it's not getting those open windows straight direct to the south, right? I can save you $30,000 a year in energy costs. And then the customer lights up and says, ooh, I'm hiring you to do this project, right? So you can make those kind of changes with that software. It's a very sustainable way to lay out structures and to calculate use and also calculate costs and all that stuff.
So in that situation where you're building the building.
Yep.
This isn't the software to design and build the building. This is just the software to calculate.
This
where
is,
it's going.
yeah, it can go there. It can get construction drawings. You can get construction drawings out of this software. It would
It's
take,
not what you want to work in.
yeah, it's really rough. You will, it'll be a love-hate relationship when you started this. It's super complicated. It's not user-friendly is my interpretation of it. It's super cool. It does really cool stuff, but I think it would take a lot of time to get it to where you could do that with it. So I know what they do with it is they sell projects with it. So it's like an architectural software in that if you come to me and say, I want to build a Pizza Hut and I want to look like this, I can model it and make it look exactly like you want it to. Right? So then you're going to look at that and go, oh, that's what I want. That's perfect. And then I can give you some energy costs on it. And then we got to slide it to the engineers to make some drawings. That's kind of how it gets used. So architects do use it a lot. Anyway, so we only spend like 4 weeks in it, have some fun with it, and run some energy models so you can at least see it. All right, good. That wasn't the best one. One of the better ones. Okay, good job. Thought I might have a good 3D picture. Yeah, that's bad. It's interesting what it can do. All right. We don't want to go down that rabbit hole yet, but we'll do that. And then the energy analysis. I think that's pretty much it. Okay. So the first part is understanding the sustainability concept. So I've shown this before. Has anyone seen it? Jorge's seen it. Remember what it was, Jorge?
Fuel, crude oil.
Yeah,
or something.
where we discovered crude oil and where it's estimated we will be out of crude oil. Yeah, it's crazy, huh? So where are we? We're right in here. We're the gluttons that are just like consuming it. But at some point it's gonna run out. And then we'll have to go some other direction, which we already are, right? We're already expanding our renewables, thinking about how to be more efficient with our crude oil. And also looking at trying to solve future energy problems. So if you're looking for a problem to solve, which my son just said the other day, all the problems have been solved, Dad. I'm like, oh boy. We have a lot of problems to solve, folks, and energy is a big one. The storage of energy is huge. We don't do it. We don't store energy. So Bonneville runs, this time of year, Bonneville runs about 50% capacity. Because Bonneville, the dam, produces what is needed. Right? So we don't need air conditioning, so it's not making all that energy. California doesn't need air conditioning this time of year. Not even Arizona needs air conditioning this time of year. So all that energy load is just gone. They don't need it. No one needs it. So we don't produce it. If you don't need it, they don't produce it because we cannot store it.
So we're losing out on potential.
All that energy that it could be producing, we could be putting in the bank somewhere and use it in the summer. We don't know how. We can't effectively store it. We have ways to store it. We have batteries, but that's not very effective for the kind of quantity we're talking, right? Tesla would like to put a Tesla battery on every house, every home. Right? If you did that, that would be the capacity we need. That would do it. We could store. And essentially, we just all have a giant battery hanging on our house. They look kind of cool. You'd be the cool house in the neighborhood if you had one. And then the grid would just keep those full. And then when it needs energy, it would pull those back. Right? And then we could take off other systems. We could take them offline that are more pollutant or that are less environmentally friendly, right? Because we still have a lot of coal powered plants in this country. So coal's it's a nasty thing. It's pretty effective. It's good at what it does, but to get it, it's pretty destructive. And then it's got a byproduct that's not so great. So we don't store energy well.
Is there an issue with like, as far as sustainability?
Well, it's not a renewable. There's a limited amount of it. So that's the issue with that kind of. We have a lot of water, right? And that just recirculates around the planet. As long as we don't destroy that water, we can reuse that water. So there's a system in Klamath Falls that takes energy and pumps water up a mountain into a reservoir. Right? So when it has excess energy that can't be used or shouldn't be used, they pump the water up to the big reservoir. And it's a big system. And it's working pretty well. Yeah, and so then when you want the energy back, what do? Cut the water loose, just like a dam, you have falling water, you can produce electricity. So that is a storage system, but it takes a lot of space to do that.
That's a really specific environment.
Yeah, a very specific environment.
Wouldn't it also be just like a net loss? How it takes to get it up there and bring it back?
The power it takes to get it up there, you're gonna get back. So it's a net loss, but you're storing energy. And there is losses that we don't get back. So it's not perpetual motion type of thing, like, right? Doesn't work that well, but your losses are pretty minimal. Your pump losses, that energy to pump it up there, you get 90% of that back when you let it fall. So those systems are pretty efficient. But we just like, where are we gonna pump it to here? Pump it up to Mount Hood? No.
When that solar, because hasn't that been the big thing, solar panel and college?
Yeah,
The energy, I don't know, they pay you. for
Yeah, so you sell it,
something.
you sell it to the grid. Yeah,
So that's not actually getting stored.
it's not, it's getting used, so then what happens is they just produce less. Which is a great thing unless you have a hydro. Their freaking hydro is awesome. So it's not so great around here because they're gonna give you pennies for your power of your solar. And then they're gonna sell you hydro back at a higher rate. So,
Why? Because obviously, I'm originally from Colorado.
Mhm.
So it's in bigger up there.
yeah,
Yeah, you know.
yeah, it tends to be a little more sunny out there, yep,
But people still.
yeah, yeah,
About, and thinking specifically of a friend of my dad's who bought a house that already had the system installed.
yep.
He was just like complaining about like feeling like he was somehow getting ripped off. I'm not sure how or why.
You're not getting ripped off, your payback is pretty long. So most people aren't in their homes 30 years, like I've been in my home for 30 years, but most people don't do that. They're in their home for 3 or 4 or 5 years and then they're off to some other home, right?
So it's better.
So you're looking at a payback of like 20 years for your solar system.
And not only that, like California has a big problem right now. Because new construction, they require solar
Yep.
panels.
Yep.
But the problem is that those solar panels are leased, they are not owned.
Yeah,
So.
that's another problem, with whether you buy your system or whether you're
Yeah,
leasing your
so
system.
at the end of the lease, now the company wants the owner
Yeah,
to buy the system.
yeah.
And some of them say, no, it's ridiculous.
No, there's a lot of traps out there for
Yeah.
sure. But a standard solar system for a standard home, it'll lower your power bill is what it'll do. So it can lower it up to, depending on what you put up there and your location and how it's done, what kind of angles you have and stuff, it can be like 50%. So it can lower your power costs quite a bit, but then you're making payments on your solar system if you just didn't pay for it flat out.
Yeah, and I'm thinking it would have been previous owners that paid to get it all installed.
Yeah.
So it's probably built in like, here's an extra.
Yeah.
fee,
Yep.
so.
So we'll play with all that analysis. When we do solar, we play with all that analysis, so you kind of have a feeling for it. It's remarkably effective. So you'll get my bias through the class, and solar is my bias. Now wind, not hydro is great, but it's just not everywhere. So wave is cool, super cool, but I don't think it's gonna get us there. Solar, there is so much energy that comes from the sun. Unbelievable amount of energy, and we capture about 12% with a standard solar panel. That's how effective it is. 12%, that's pathetic. So
Is that something that we're making consistent?
we have,
They get
we
better,
have,
better?
we have it better, we just don't have it cost effective better. So you're not gonna go, you can go buy a panel for $300, pretty good sized panel. And that thing's about 12 to 15% effective. You can go buy that same panel for about $4,000 and it's like 60% efficient.
Oh,
So then you do the math on payback on that and it's like, oof, that's rough. So we just need to get it perfect. Nuclear's the most incredible energy source there is. Like, we'll talk about nuclear just a little bit. It's phenomenally efficient, incredibly efficient, and so much energy per mass, right? It's just has some dangerous parts to it that we've mastered, but then there's been some problems and, some difficulties with it, and that has lingered long in our consciousness, so. On the way to San Diego, you pass 2 nuclear plants right on I-5. Nobody knows it's a nuclear plant. Like you're driving by, everyone just thinks it's a dome. Like, is that an observatory or what? No, that's a nuclear plant you're driving by. And they're super effective. It's at that military base just before San Diego.
there's like an international project in
It's
France.
another one.
I don't know what that military
There's
base
like an
is. It's
international-
right before San Diego. I can find it.
Korean base, right?
Yeah,
What?
yeah. If you say it, I got it like that.
There,
I was just there.
there's an international project in France. It's a experimental nuclear fusion plant.
Yeah.
They're trying to do fusion.
Oh, Pendleton.
They're trying to
Yeah,
figure
yeah,
out.
Pendleton. That's,
Oh.
yeah, yeah.
They're trying to figure out nuclear fusion, because fusion's cleaner than fission.
Yeah.
Uh,
There's a bunch of work in a lot of areas. Fuel cells, super attractive.
But
Like-
like, if they can figure out fusion, they could use like a water bottle. You're getting like
Yeah,
however many, like it's equal to however like hundreds of barrels of oil.
yeah,
Okay. The
yeah, there's a
problem with that-
lot of work in energy,
The
big,
problem with that is also that you need the storage space for the.
that's exactly right,
Yeah,
yeah,
The submarine, that, a nuclear submarine, that's how they get the water. They do a reaction, and they separate the oxygen and hydrogen, and they store the hydrogen and the water, they use it, and the salt, they just put it back in the sea. But,
yep.
they can't store it that much.
All right, here's another one of my favorite slides. It's the galaxy. Right? And here's our sun. And the question is, where are the aliens? So the question to you is, do you believe in aliens or not?
Statistically speaking, almost certain,
No, I'm not gonna comment. I just wanna know what you think. Like, do you think there's aliens out there or not?
yes.
Well, I think there's life, I don't know about like civilization.
Right.
But there's
Something else out there,
there's enough planets close
Yeah.
enough to a sun.
Yeah.
There's like a sweet spot.
right?
Where they have to be close enough to the sun, there's enough planets that we've
Yeah.
identified to make that almost a statistical.
And that's like, saying yes to this is a very popular mindset.
I think it's less about like, if there is aliens, it's more about the distance between. Yeah, like,
So
Right, doesn't even matter.
how do you think, why would you have that conversation in sustainability? Whether there's aliens or not, what's that have to do with sustainability, right?
technology.
Up there on the plans.
Options, that's exactly right, it's options. So if you believe, so here's what the research says. If you believe that there is alien life out there, then your tendency is less to take care of your planet. Because you believe there's possibly a place to go. If you believe there's absolutely no aliens out there, and this is it, this is the one dot in that entire galaxy that was able to pull off you all, then you would, your whole focus would change and your entire existence would be to take care of the planet. Because you got nowhere else to go.
Well, I mean, even if there is life 15 billion light years away, it doesn't help you at all.
True.
if You have no method.
True, but subconsciously, they say, research shows, if you believe there's anything out there, then you're less likely to take care of your home. Which I thought was just fascinating. So then I'm like in the habit of asking everyone, hey, do you believe in aliens? And everyone's like, oh, yeah, for sure. I'm like, oh, there we go. Maybe this is true. Anyway, it's fun to think about.
Do you believe in it?
That's a good
Do you
question.
believe that that's
I don't believe that we're the only cells that split. Now, I don't know that any others survived.
Right.
But I don't know that, nobody knows that kind of thing. But my mindset is more of, so do you believe in multiple, yeah, no kidding, multiverses. Do you believe in multiverses? So that would be more than one universe, right?
Just
Yeah.
in this image, right? So like one star to another star.
Yeah.
The time that light has
Yeah.
reached us.
Yeah.
50 million.
That's right.
civilizations.
So it's really hard to comprehend this thing right here.
So statistically, it's like, yes.
So the concept of multiverses, I think, is fascinating. And also the concept of it took an unlimited amount of multiverses to get that universe that held together. And then it took all of that to get one of these that worked. So I think that's plausible. Because how we evolved, regardless of like, what you believe there, is pretty phenomenal. Like, really, could that have happened somewhere else? And if it did, I don't know. That's crazy. Anyway, it's fun to think about, and I think it's good to think about when you're thinking about sustainability. Because if this is the only dot, then we should probably start like turning the lights off a little bit at night. Yeah. All right. So let's talk about this.
Actually, can I ask something about
Yeah.
what you just said?
Yeah.
turning the lights off.
Yeah.
We have, like you said, Bonneville Dam's not even putting out as much as we need.
Nope.
We have access to
More.
the electricity.
Yep.
What is the problem with using the electricity?
Nothing in the hydro. If you're okay with hydro, and if you're okay with that dam being there and doing what it does to our river, I mean, it's already there, you know, doing okay, we're getting better with fish kind of thing. If
The
that's,
problem is the wildlife, right?
if that's okay, then there's no, it's not hurting us a lot. That dam's not. It is by far the best. If you want to put in the renewables, it's by far the best.
Okay.
But we had to dam up a river to get it.
What
So
percentage of
that was cool.
electricity comes from
Huh?
the area? What percentage of like the total use comes from the dam?
100%.
Yeah.
Oh, really?
We are completely hydro. We sell it to California. We have so much extra. Yeah,
Is the
yeah, we are
transportation
all hydro.
difficult, or is it pretty? I don't know much
That's
about
the
it.
other thing, people. Do you know how we transport energy?
They're not power line?
Just stupid power lines, like
Yeah.
1901 power lines is how we transmit energy.
Uh-huh.
So if y'all can come up with a new way to like shoot energy,
Isn't a lot
I
of
mean, a
energy-
laser's energy, but that's really gonna take people's heads off if
There's
we
like
use
a lot
that.
of energy lost over.
Tons.
Like
Tons.
converting it.
What was the question? How did I get there? Like, how do we,
What the issue is, with you said turn the lights off,
right,
you know, if we're not hurting for energy, if we don't have, if we're.
if
not
the
fighting for
production's
energy.
not killing us,
Right.
what's it hurting? It's not hurting anything in our area.
Okay, but
If
that's
you're
specific
not
to
in
us.
this area, then you are probably in a coal-fired power plant. And it's burning coal. And that's a limited resource, not an endless resource. And it's very pollutant and it's very destructive to dig the coal out of the ground, these giant coal mines, right? So if you're there and you leave the lights on, then you're kind of chewing up the planet kind of thing. Other areas might have an oil-fired power plant. So that one's, you know, burning a renewable, a non-renewable up.
Is there a limit to how far we can send it? Like, there's gotta be, I don't know.
You mean-
but if there's enough places.
Via
in-
power line, you mean? Via cable?
Via however we do it.
Yeah,
there's
we
gotta
s-
be enough moving, or I'm guessing, there's a lot of moving water in the states. And if we were to utilize that, are we able to send it all over to where? If
We're pretty
hydropower-
good at transmitting the power.
Okay,
There are losses because we can only send it so far to a substation. That substation collects it and then resends it.
Oh.
Using a more boost to get it there.
Okay.
It's dangerous, as we learned, right? Power lines get hit by trees during windstorms and then start fires and then burn up communities and kill people. So that's not great.
A lot of people.
It's very archaic how we do it. Super
well, it's
archaic.
just because we're building stuff that's already, like the power lines. were
It's
already in
because we
place.
haven't come up with another way. We have no other way to get electricity from me to you.
Well, can we just put on, what can we just put on the ground? That seems like that would.
We do in certain areas,
Get
but
the
that
plates
is
and stuff.
super not cost effective.
Oh, super expensive.
Yes, super expensive.
Even Brasilia, the capital of Brazil,
hmm
implemented the underground line back in the eighties and didn't work because it's too costly to make it.
Yeah.
There's a number of things, there's a number of problems with it. Getting underground's hard and then it's underground, which is a very moist, wet environment.
Yeah.
Above ground, it's actually a lot drier.
Yeah.
You know, water just runs off it and it doesn't hold water around the system that we're using to transmit.
And if you need to repair it. it's there,
Yeah.
you know.
It's a lot easier to get to.
Yeah.
You know, the ground does this kind of thing. So if you're underground, it does this.
Yeah.
It's a problem, but if you're above ground and it does this, then the cables just go in like this.
Yeah.
Maybe don't fall
Did you say you
in.
can send it with a laser?
A laser is energy and you can shoot it, right? You
You can
can,
shoot it a satellite and then shoot it back.
yeah, so you can shoot a laser to a location, that location can capture the laser and now you're transmitting energy that way.
Yeah, but we creating more.
Super dangerous. Yeah, Normally, if a laser is like locked on you, that's not a good thing. So,
But, question on that, okay, so.
love this class. This is the
If you
best
shoot it-
class.
If you shoot a laser, it's creating also sonic waves, and it might interfere with something else.
Yeah, so, well, you have to,
It's light though, it's not a,
Uh,
wait, does it still break the sound barrier?
okay, what's the principle of displacement? Archimedes? Anyway, whatever you send, doesn't matter if it's light, it will display something. So that's anti-gravity waves.
Oh, okay. I see.
I thought light had, didn't have mass, but
Might be above my pay grade on this kind of topic. Laser technology is pretty cool.
because light is a wave. or something like that.
It is, but I think lasers have mass to them, so I think they might be different. I don't know. I don't know, but it's an interesting problem that we have in transmitting energy, right? Storing it, transmitting, big problem. All right,
If they just take down the whole house, take it down.
just remove it.
My husband's uncle has been in the industry for a long time. But yeah, I forget where we were touring, like, yeah, they stopped doing them.
Yeah,
Tunnels.
it's changing, it's changed a lot.
Take it down.
Yeah.
Whole mountain down,
Yeah, if you drive
then they try to like,
south on the inland route, not I-5, you go by several coal mines that are pretty phenomenal. Or they're literally just removing mountain ranges. So,
I think he's. Wyoming.
yeah, oh yeah, Nevada.
Yeah.
It's tough
Silver
because
City.
that is it's a huge, like, we'll talk about petroleum and petroleum is like gold as far as the amount of energy in a small little, I don't have my petroleum bottle, but I'll bring it in that little bit of petroleum is incredible. So that's why we love it so much, is it really is very, very efficient. It's not nuclear, but it's pretty close and you can get it a lot cheaper. So it's very attractive. It's hard to figure out how we're gonna get off of it. It's just gonna run out. All right, so here we go. We want to define sustainability. So I'm going to give you a few minutes to kind of develop your own idea of what you think it is. You can kind of couch it around engineering if you want, because this is, you know, sustainable engineering, right? So think about it a second and think about what you think a definition could be. And then we'll be done. All right, I'm ready for suggestions, offerings of opinion on sustainability. And capturing. What do you think? What's that?
Topic. Being able to do something and rotating that thing doesn't destroy your ability to do it later again.
Ooh. How am I gonna write that?
I wrote the measure of a system's ability to do its purpose.
We repeat? Is that what you were thinking, Juan?
Guess that's pretty good.
So if you had a system, it's operating, is there anything else about that system?
I will maintaining the current environment while also maintaining growth.
Oh, I should have wrote maintaining. So maintaining the current environment maybe while the system does this repeat thing. Right? Because we don't just want it to repeat and destroy the environment or destroy the air, right? Or the water. We want it to maintain the current environment. Okay, good. What else? What do you got, Jorge?
For me, it's, finding ways to store, utilize, produce, and distribute energy without interfering or destroying our environment.
So yours is focused on energy, sustainable energy. Yeah, love it. Anyone else? You don't have to offer.
Responsible.
Resources. So what are our resources again? Air, water, land,
Space.
space, land. There's one I didn't mention before. Human resource, right? We don't want to do things that are gonna like hurt the human resource that are involved. Good. Anything else? I think it's pretty good. Let's see what the Confederated Tribes came up with. So this is the Confederation of Indian Tribes. It goes way back. Their definition of sustainability, which they've had for hundreds of years, is that. It's pretty good.
Pretty impressive.
Yeah.
Come up with it before.
And they came up with it like way before 7 generations. And
you
they were effective at it for,
You would think there wasn't
many-
enough that they could do to destroy
Right.
anything.
right. So that's good. We're gonna continue to try and define it. If you Google a definition of sustainability, you're gonna get like crazy stuff. Like a lot of sustainability is very focused on a certain area, right? So it could be energy sustainability, it could be transportation sustainability, it could be clothing sustainability, all kinds of different areas. You have a lab to do this week, and it is on the homepage in Blackboard, but I'll show it to you because I want you to kind of understand what it is. Where is it? Oh, am I in the right class? Yeah, I am. Oh, I know where it is. It's in the submission area, is where I put the. So in the calendar, it says lab 1, see the submission area, forgot my own notes. So in the submission area, lab 1 says, after watching the MSU video on sustainability, do this. Okay, so watch this video first, and I have the link to it here. It's not very long. Introduction to Sustainable Engineering, MSU. Okay, so watch that and then go to the submission area and answer the questions.
Then on Wednesday, somebody will be able to.
Yeah, and then on Wednesday, I'll have another lecture, just like I just did, but it'll be recorded and it'll have you do something else. I'll probably start moving you towards your project. You have a project in this class, and I'd like to get it started soon. So this PowerPoint is on Blackboard. You could go look at it. I haven't gone through the whole PowerPoint. I just put a big one up and then I pick away at it as we go along. But you have an project to do. I call it an project. You can read through this and I'll probably talk about it more in the recording later this week. This is not an effective due date. I need to edit that. But essentially what you're gonna do is you're either gonna produce energy or you're gonna reduce a resource in this 10-week term, probably only 8 weeks when you get to it, right? Because we're gonna define it for a couple weeks. So it's your choice. You can produce energy, you can make something that produces energy. So that's kind of fun. You can make a little wind turbine, you can make a hydro system. As I go through them, you can choose what you want to make if you want to be a producer. If you want to be a reducer, then you can think about the resources that we've already talked about, and you're going to try and reduce resources in your life over an 8-week period. Okay, so if you're going to do a reduction, we have to do a baseline first. So for example, a very common one that students do that's pretty easy is you try to reduce your waste, trash, right? So you would go 2 weeks, normal operating procedure, and you would quantify the amount of trash that your household is producing. And you're in a household, so it's like you got to get buy-in from everybody else or it doesn't work. So that's part of my motivation too, is if you go down that path, you got to work with your roommates or family or whatever and get them on board to this damn thing, right? Yeah, exactly. You can reduce water. That's pretty easy. If you're on a water meter, you already got your data. You don't even have to look at your baseline. Now you just got to try and reduce the water use that you have. Transportation, you could try and reduce the amount of times you drive. We talked about the bus a little bit in another class. So we could switch up our ability to transport ourselves and try to make that more sustainable. So you have a lot of different areas, a lot of different directions this thing can go. But I'd like you to start thinking about it. So for example, if you wanted to produce, that's an example of a wind turbine that was made in this class. It's got to work, whatever you decide to do. So when we get the big easterly days, we can take that little wind turbine out and set it out here in the corridor, and it lights up a little LED that you'll see on the base, proving that it works, right? It's got a little generator in the tower. It's pretty fun. Of course, we never got that easterly day, so we couldn't prove it. So I brought in my leaf blower and we just stood there and blew it and it lit the light. So,
Have you
perfect.
seen the new turbine?
huh?
Have you seen the new turbine that they want to implement instead of the 3 blade design?
Oh, yeah,
now
yeah,
it's
yeah.
2,
Yeah.
generating
super cool.
much more
Yep.
energy.
And I have like an 8-foot one at home that I hoped a high school kid built for his senior project. And I told him I'd buy all the parts if I got it when he was done. He didn't want it anyway, so I got it. So I can bring that one in too. It does produce. Yeah, it's got a generator on it like this big. So I've had it in Primeville for a while because we get some wind out there. The problem with the homemade one is their startup force is so high. It's got to be hell for windy to get it going. Where the produced ones that are, got the fancy bearings and they're super efficient. Those things are low startup. They'll start up at 10 miles an hour. The one I have at home, I think it's got to be blowing like solid 25 for it to start up. Then it just goes like crazy,
Yeah.
and it'll keep spinning down to like 15. But startup, it needs.
You just like,
You could, if you were there, if you're like standing next to your wind turbine, get that puppy going.
right.
No. All right, so start thinking about that and do the lab. And then look for the extra lecture Wednesday. You can have a great day.